各位 SES 的伙伴们和关注 SES 的朋友们，大家好，欢迎来到2022年 SES Battery World。我的名字是许阳 ，SES 中国区投资负责人。Battery World 是 SES 1年1度的传统活动，我们从事锂金属产业，初心是为世界打造成本经济、实用安全、高能量密度的锂金属电池生态系统。SES 从2012年麻省理工学院地下室的实验室，发展到今天将近200人的上市公司。这一路纵然困难重重，我们仍然信守初心，信心十足。SES 是一个公开透明、充满活力的组织。借此活动，我们希望向公众展示过去1年的真实进展和未来的远景规划。此次活动是我们继去年首届活动之后举办的第2次 Battery World， 感谢您的参与。去年 SES 创始人兼首席执行官胡启朝先生发布了一些关于4安时电池的喜人数据，并且首次展示了车载100安时锂金属电池。上个月我们又发布了关于50安时电池的新数据。尽管还有一段路要走，但毋庸置疑的是 SES 在下一代高能量密度电池的竞争中处于行业领先地位。世界电动化的趋势不可阻挡，各国都在不遗余力地为实现碳中和制定战略规划，并努力付诸实践。在这样的背景下，我们作为锂电池产业链中的初创公司，也需要未雨绸缪，在多元的世界经济中逐步搭建自己的供应链系统，为锂金属尽快实现与车企共同开发协议的落地和未来的商业化量产奠定坚实的基础。接下来，启朝将为各位讲述 SES 的最新进展，包括如何大规模地制造锂金属电池，以及如何解决未来供应链的挑战。演讲结束之后，我们将进入问答环节。您如果在收看直播的过程当中有任何问题，欢迎在直播间留言，我们将随机抽取部分问题，请启朝作答。接下来有请启朝。
大家好，欢迎大家参加2022年 SES Battery World。2022年是非常艰难的一年，这一年里发生了战争，经济面临更大的不确定性，因为疫情不得不采取封锁，供应链的挑战加剧。SES 同样经历了困难的一年，困难的程度甚至超过了我们的预期。但与此同时，我们也取得了很大进展，就像穿行在隧道中，现在隧道尽头曙光出现。在去年的 Battery World 上，我们回顾了电池的发展历史，知道了每隔30到40年，电池的能量密度就会翻1倍，以及为什么对于汽车和未来的空中交通而言，锂金属电池会是终极解决方案。我们也展示了混合锂金属电池和传统锂离子电池及固态电池相比所具有的优势。传统锂离子电池虽然能量密度比较低，但不管是制造工艺还是供应链的发展，都适合于规模化生产。固态锂金属电池理论上具有高能量密度，但离真正的商业化还很遥远。混合锂金属电池则能兼顾两者的优势，它的制造工艺和供应链与锂离子电池相似，能够实现规模化生产，同时又具有固态锂金属电池的高能量密度。去年，我们也展示了世界上第一块100安时的锂金属电池，宣布了在上海建造超级工厂，也是世界上最大的锂金属电池工厂。那么在这一年，我们做些什么呢？其实挺多的。 进展还是挺快的。目前在上海已经做了1000个50安时、100安时电池，但是随着我们生产的大容量锂金属电池越来越多，我们发现了很多问题：制造工艺的问题、设备设计的问题、材料特性和工艺的问题，还有电芯设计、化成条件、循环条件等等方面的问题。所有这些问题都是我们在制造小容量电芯的时候没有遇到过的。我们可以无视这些问题，继续生产，但是抱着宁缺毋滥的态度，我们还是决定放慢速度，先从根本上弄清楚和解决遇到的问题。我们花了非常多的时间对电芯材料、工艺、设备进行细致的表征，进行电芯拆解、分析等，甚至专门为50安时和100安时电芯设计和开发了新的表征设备。我们还建了装有 AIoT 传感器的机器人，在充满电的情况下拆解大容量电芯。通过这些方法，我们获得了非常有价值的信息，也为我们训练 Avatar 系统对于50安时和100安时大容量电芯的预测能力奠定基础。在过去几个月里 ，Avatar 对大容量电芯的安全预测准确率从0提高到了将近60%。相比之下，经过4年的数据训练，4安时锂金属电芯的预测准确率已经超过了99%。最近，我们公布了50安时锂金属电芯的性能和安全数据。我们已经和所有的 JDA 车企分享了这些数据，并且给部分车企寄送了电芯。明年，我们会向所有 JDA 车企寄送电芯。与此同时，我们还和全球其他几家 EV 和 eVTOL 公司分享了相关数据。这张图展示的是50安时锂金属电芯在1/3放电条件下，从室温到0度到零下15度到零下35摄氏度都具有出色的低温性能，在室温高功率密度下的性能也非常不错。在第三方安全测试中，我们通过了穿刺、过冲、外短路、热稳定测试，而且都没有发生热失控。我们的50安时电芯还获得了 UN 300.3安全运输认证。这个还只是数据，下一步我们要去验证电芯到底能否可行。去年，我们的4安时锂金属电芯能够让一辆卡丁车跑起来。今年，我们做了更大胆的尝试。我们和一家非常酷的 eVTOL 公司风飞 Autoflight 合作，验证我们最新的100安时锂金属电芯。 把锂金属电池应用到 EV 头上简直太棒了。希望有一天这些能垂直起飞降落的无人机会更加普及，让人们的生活更加便利。那么接下来我们应该做什么呢？过去一年，我们学到了一件事，就是要全方位的满足车企需求，我们需要把控每一个细节。对于锂金属这种下一代电池技术来说，所有这些细节组成了我们的供应链。这并不是想不想做的事，而是必须要做的。如果不这样去做，是无法全面满足车企对于电芯产品的要求的。对一家仍处于 A 样品阶段的公司来说，担心供应链的问题似乎为时过早。但是供应链事关细节的把控能力，这一点让我来解释。这张图展示了我们的供应链，从矿到冶炼到电解液所需要的盐、溶剂、添加剂、隔膜、前驱体、正极、锂锭，然后是锂金属负极。因为我们做的是锂金属负极，所以我们的供应链会注重负极。之后再生产和测试设备，再到锂金属电芯，然后再加上电池健康检测软件 BMS 电池包，最后到实际应用，然后回收。从上游到下游，整个过程中产生的所有的数据都会通过 Avatar 系统来追踪。当我们还未达到商业化的时候，仍处在研发 Pre-A、A 样品和 B 样品这一阶段的时候，供应链的重点在于获得自由度。只有最大化这个自由度，我们才能从系统层面解决问题。此后，当我们接近商业化，也就是到了 C 样品量产甚至更进一步的时候，供应链的重点就变成了保障供应、确保质量和降低成本。2015年以前，我们处在早期研发阶段，当时的注意力全部集中在了电解液上。虽然在电解液上取得了不错的进展，但当时几乎没有能力去改进电芯整个系统。2017年，我们开始研究锂盐、溶剂、添加剂、隔膜涂层。当时我们从单纯的材料研发转变为自己制造电芯，我们有了更大的自由，对系统有了更多的掌控，因此能改进的东西更多了。2020年，我们在 Pre-A 样品阶段，我们设计了新的生产和测试设备和电池健康监测软件，自由度也进一步提高，对系统的掌控也加深一步。能改进的地方更多了。现在我们在 A 样品阶段，我们把更多工作转移到公司内部自己完成，比如不同的负极加工工艺、正极加工工艺，以及更加成熟的 Avatar 数据收集训练平台，自由度也变得比以往更大，对系统的掌控也更进一步。未来，当我们进入商业化阶段，还需要加上矿和回收。全流程的掌控，并不意味着所有事情都由我们自己来做。每一个组成部分，每一个步骤都会影响电芯的最终性能。我们要花精力去深入理解它是怎么影响整个系统的。全球供应链正在向区域供应链转移。目前我们在 A 样品阶段，很快就进入 B 样品。我们的产品还没有商业化，所以我们要充分利用当前的全球产业链，以最高效的方式走进商业化。进入商业化阶段后，我们会根据实际需求，与合作伙伴一起建立本地化的供应链。2022年是非常艰难的一年，我们仍在黑暗的隧道中前行。电池公司、新能源汽车公司可能都要经历这样的过程，没有捷径，但我们相信希望就在眼前。谢谢大家，请大家继续关注我们，谢谢。
好， 非常精彩的展示，也为我们 SES 全体员工过去1年的努力和付出点赞啊！接下来是问答环节，我们先请启潮上线。启潮，请你给大家打个招呼 ，say hi。
大家好。
好，我们在直播间里面也搜集到了一些问题，我们就选一些来提问，也请您帮我们回答一下啊。第一个就是呢，目前公司已经发布了一些4安时还有50安时的这样一个数据。那么对于我们的车载大电芯100安时的锂金属电芯的数据，您觉得什么时候可以跟大家分享一下呢？
我们其实目前内部已经有一些100安时的，但是更稳定的话，明年中旬。
明年中旬 ，OK， 那我们也期待能够看到更加精彩的一些数据分享啊。OK， 那第二个问题。生产这个100安时锂金属电芯最大的挑战是什么？
很多很细的挑战。
最难的
有一点就是
什么？
我们生产锂金属是用锂离子电池，然后很多问题其实是锂离子电池其实是已经经历过的问题，就是我们可以用锂离子的经验去解决。最难的主要是负极，这个锂金属负极，这个超薄超宽的锂金属负极，目前全球没有人在生产这块，我们之前是从供应商采购，目前是内部自己做。锂金属负极这个目前最难。
那我们觉得什么时候可以能够打通整个锂金属负极制造的一些个困难，然后完成我们自己的一些个中试呢？
目前 A 样品的时候，还正在做，然后到明年准备进入 B 样品，明年下半年这块应该会初步会打通。
好的，感谢啊。OK， 那么第3个问题是，我们目前跟几家车企的这个 JDA 的合作进展如何？
目前3家，然后都在 A 样品。其实问题都是挺类似的。就是解决这些问题，如果一家进入 B 样品，所有都进入 B 样品，我们是预期明年下半年能够解决这些核心的问题。像你刚刚说到一些生产问题、一些性能问题，下半年希望就是大家都一起进入 B 样品。
也希望我们能够顺利啊。如果要是有一些个 milestone 的话，也希望能够听到公司从 PR 的口径有一些个宣传。OK， 那接下来还有一个问题是关于刚刚我们也放了一个非常酷的一个 eVTOL 的一个视频。那么您认为这个锂金属电池会率先应用在 eVTOL 领域吗？
锂金属电池其实最大的优势，它是很轻，它的体积能密度有优势，但它的重量能密度其实优势最大。锂金属应该会在无人机还有就是载货的 eVTOL 应该是最早实现，甚至是25年之前实现，然后25年、26年会在载人的 eVTOL 和EV 上实现。
您觉得就是 eVTOL 作为我们的除了 EV 车企之外的合作伙伴之外的话，它对于我们整个锂金属电池的技术上面有没有一些个不同于 EV 的这样一个改进的方向？
因为其实像 EV 的话，锂金属是提高很多一些指标，像一些续航里程，但是对于 eVTOL 的话，锂金属它不光是提高一些续航里程，它是完全一个 enable， 就是eVTOL，因为那个非的eVTOL 其实对重量的能密度是非常重要。然后锂金属目前不管是硅负极也好，还是其他的电池是没有能够和锂金属电池在重量能密度来比的。
OK， 明白。行，那我们在刚刚 pop 进来一个问题，关于 SES 的 solvent in salt 电解质的流动性，它本身流动性是怎么样的？那是凝胶态还是流动态？我觉得启潮这个是相当于在询问我们自己的这个电解液，也就是高浓度锂盐的电解液的一些特性。您要不然展开跟大家介绍一下？
我们的高浓度电解液其实是一个挺特殊的材料。 包括盐，包括溶剂，其实溶剂是自己合成，在市场上是买不到的，它整个是流动态的，并不是胶状，然后这个也是我们很长时间10多年，还有就是一个挺强大的一个电接团队，应该在全世界锂金属电接方面应该是最强的，然后就是开发研发做的最深的，花了很长时间开发出来的一个特殊材料。
那你觉得它搭配在目前其他的一些个，比如说锂离子电池上，会有更高的特性吗？
有可能，有可能，因为其实像锂离子电池，特别是低温的时候，它会镀锂，就是锂离子电池在低温的时候，它会变成锂金属电池。然后锂离子电池里面的电解其实很难解决低温这个锂离子变成锂金属的这个问题，但是我们的这个电解，其实就是为锂金属设计的，所以应该对锂离子低温应该会有好处，但是当然，我目前主要的精力还是做锂金属电池。
明白，明白。好，那我们进行下一个问题了啊，就是说 SES 目前的全球有3个研发中心，那么Boston 啊、上海啊，还有韩国，在定位上面有没有什么差异和区别？
挺好的。波士顿主要做一些基础的化学研究，一些基础电极液的研究，主要是电极液。然后在韩国做一些正极的开发，还有一些设备工艺的开发。然后上海做会比较广，上海就是电芯工艺的开发，负极电极液生产工艺的开发，整个电池产品开发流程管理，质量管理，还有就是软件算法、采集数据，还有就是最后把一个材料放到电芯，放到整个模组，加上这个算法，然后放在一个比如说像一个 drone 一个 eVTOL 这样的一个应用领域的一个开发。上海做的是更广一些。
确实，我们中国的整个的锂电产业链的产业化能力还是非常强的，速度和效率比较高。OK，那下面一个问题呢是关于整个技术方面的了啊，就是说倍率放电的最大支持目前是有多大？因为锂离子本身和锂金属它的测试环境应该还是有一定差异的，就是说我们在进行电池测试的过程当中，我们是怎么去尽可能的模拟实际的一个工作状况的？
第一个问题就是放电最大的倍率是吧？锂金属电池其实在放电的时候，它是非常适合高放电倍率，就是像无人机，特别是起飞降落，还有车，锂金属在放电的时候是可以支持很高的放电倍率。目前我们测过5C、7C 甚至10C 都有的。然后第二个问题是怎么去模拟这个锂金属电池在真正
工作场景当中的应用，对的。
对，这块其实我们跟车企合作，其中一块很重要的是车企，它会提供给我们车企本身在不同的市场、不同人采集的这个真正的应用场景的测试方式，然后我们会用这个测试方式来测我们的锂金属电池，这个是车企提供的。
OK， 明白。下一个问题是关于 Avatar 了。咱们直播间里面有一些个朋友在问，就是第一点，咱们这个 Avatar 的软件，其他公司能不能用得到？也就是说，跟其他一些公司系统的一个相容性。那第二个是，如果能用得到的话，公司会不会考虑给使用权啊，出售一些使用权啊，或者一些个方式，来给其他的电池公司使用？那第三个就是。公司觉得什么时候可以把 Avatar 应用到其他的一些个电池公司领域当中去，然后以及以什么样的成本？
我们Avatar 是为锂金属电池设计的，就是 Avatar 这个软件算法和锂金属电池是配套的。如果把这个锂金属电池换成其他的锂离子电池，整个这个算法的这个训练、机器学习这个流程是需要改的。我目前主要是把这个用在锂金属电池。 如果是换成锂离子的话，我们其实是可以也是可以的，就是要收集这一款锂离子电池它的相关数据，然后用这些相关数据来训练这个算法。但是目前主要还是把这个用在锂金属电池。
OK， 是的。OK， 那下面一个问题就是有些个朋友们也在问啊，就是说，现在行业里面有一种观念，觉得锂金属电池本身是一个过渡的一个技术，最终可能还是会往全固态电池的这个方向发展。那我也知道您在固态电池方向的研发上面也是有10多年的经验，所以也听听您对于这个问题的一些个看法。
不太同意。就是其实行业对固态电池的这个定义其实不是很明确。固态电池是锂金属电池的一种。我目前做的锂金属电池，然后不管是液态的还是混合的还是固态的，它的能量密度是正极和负极定的。就是锂金属电池，你液态、固态，它的能量密度是一样的。并不是说固态电池它的续航里程会高一些。我们认为，最终的这个目标不是固态，最终目标是锂金属。不管是液态，不管是固态，最终目标是锂金属。所以我们不太认为固态是最终目标，最终目标会是锂金属。可能中间的会是一些什么硅负极，或者说是一些固态的锂离子电池，可能是中间的一个过渡的，但是最终目标一定是锂金属。
我明白，那这跟行业里面的一些个想法还真的是不大一样。收到。OK，那么现在大家也都在谈供应链啊，就是您觉得作为我们锂金属电池生产商，供应链上面最大的一个挑战是什么？
我们锂金属电池生产商供应链最大问题是锂金属负极。目前这块很乱。然后就是这一块，其实很多供应商在锂金属电池这一块，很散很乱，然后花了很长时间去优化一些不该存在的一些产品。这一点其实是个挺大的问题。很多人认为锂金属电池这个锂金属负极就是锂压铜上，然后用真空度、用滚压、用不同方式去做出这个锂压铜上的这个产品。但其实这个锂压铜上这个产品不一定是一个应该存在的一个产品。然后很多企业花很长时间去优化这个产品和这个产品的工艺，其实这个是不太合理的。我们其实锂金属负极，首先就是我们其实和其他的锂金属电池供应商一个很大不同就是我们和车企直接对接，我们知道这个电池它需要达到什么样的要求，然后这个电池达到这个要求，这个负极得要是一个什么样的。而不是很多一些做锂金属负极的一些供应商，他们只知道一些比较有限的一些要求，然后去做一个不应该存在的一个产品。但是我们是直接和车企对接，就是按照这个锂金属电池满足上车的要求，它会要求一个什么样的这个负极，然后根据这个负极会从拟定开始，然后就是开发一个新的一条工艺，而不是像目前比较散、比较乱的去开发一些不应该存在的一些产品。
明白。好，收到。那其实就是在我们结束 Q&A 之前，还有最后一个问题，我也想代表大家问问您，这个也是走到中级商业量产之后，您觉得锂金属电池比锂离子电池的成本上面会不会有优势？
会有。因为其实你看锂金属和锂离子正极是一样的，生产工艺是一样的，隔膜也差不多，电极也差不多。其实唯一的差别就是锂金属它是用这个锂在铜上，这样的一个负极材料。锂离子的话会是用一个石墨加硅在这个铜上，所以其实差别就是这个锂金属的这个锂的这个材料，当然不一定是纯锂，可能是一些优化的一些锂类的一些材料，和这个硅和石墨混合的这个材料比，硅和石墨其实它需要锂做补锂。就是整个工艺其实更复杂，然后加上回收的话，锂金属它即使是混合锂金属 的这个负极材料，它的回收也会比石墨和硅整个回收工艺会更容易。就是终极量产的话，锂金属电池最少成本会和同样正极、同样生产工艺的锂离子是一样的，然后甚至会更有优势。
明白，收到。那我们也很期待啊，期待我们锂金属将来有一天能够量产。OK，那启成，我们 Q&A 环节基本就结束了。那最后您还有1分钟的时间，要不然跟大家再说几句？
我觉得2022年就是我们第一次开始做这种大的锂金属电池，就是全球也是第一次尝试做这种大的锂金属电池，碰到很多问题，解决了很多问题。但我觉得1年下来，就是整个这个锂金属这个方向是对的。然后我们的2块，就是一个是用一个系统的解决方案来解决锂金属电池的问题，和用锂离子的生产工艺来生产锂金属电池，这2条其实也是对的。当然很多问题，但是因为这2条的话，我们其实还是能够解决这些问题，而不像我们的一些竞争对手，其实今年做锂金属的其实碰到很多问题，然后就很难往前走。但是我们因为这2条一个系统的解决方案和用锂离子的生产工艺和用锂离子的产业链来解决锂金属问题，使我们能够解决目前碰到的这些问题。然后在明年2023年，我们应该能够解决这些问题，然后进入到下一步，就是逼样品。
好，感谢，那还是让我们坚定信心，这个勇往无前的走下去，期待能有更大的成功。行，感谢启超，您可以下线。
好，谢谢。
好，接下来我知道很多人期望听我们 Battery World 的 Industry Panel。OK， 今年的 Battery World， 我们非常荣幸地邀请到了行业中的企业和专家，以下一代的电池供应链为主题，阐述各自的努力、遇到的挑战。他们是 Ivanhoe 矿业和 Ivanhoe 电气创始人兼执行联席主席 Robert， 通用汽车电气化战略总监 Tim， 现代汽车全球研发专家永俊博士，本田汽车技术研究院先进技术中心资深工程师 Josh 先生，天齐锂业高级分析师雷爱佳女士，以及 SES 创始人兼 CEO 胡启超先生。接下来，让我们进入行业论坛环节。
Hi, next we've got our panel of esteemed experts, and I'd like to introduce our experts, and we're going to have a bit of Q&A looking at some of the stuff that Chichao talked about, and also some of the supply chain challenges ahead of us. So first, I'd like to introduce Tim Gru, who is the Director of Electrification Strategy at General Motors. Then next, I'd like to introduce Dr. Yongjun Zhang. He's a global R&D master at Hyundai Motors. Next, we've got Dr. Josh Fujiwara. He's an expert engineer at Honda's Innovative Research Excellence. We've got Robert Friedland. He's the founder and executive chairman of Ivanhoe Mines and Ivanhoe Electric. Next up, we've got Alice Lei. She's a senior analyst at Tianqi, the big lithium producer. And finally, last but not least, we have Chichao Hu, is the founder and CEO of SES. Hi, everyone, and thanks for joining us. So to start off, I'd just like to ask all of our esteemed panelists to just respond a bit to what Chichao has just said. How are you thinking also about introducing new technologies to the market, such as lithium metal? So if that's okay, I'd like to start with Tim from GM. Tim, what do you think?
Oh, thank you. And it's a pleasure to be here. So thanks for having me part of this panel. We're very excited about this type of technology and accelerating it into the marketplace. General Motors actually has a dedicated electric vehicle architecture that we call Ultium. And we specifically designed it so it could accept this new technology with minimum disruption to the actual architecture and the manufacturing process, and the ability to get it in as quickly as we can as we expand our scale moving forward. And so we think that we're aggressively pursuing this technology and trying to accelerate it as fast as we can. We think we've proven durability with SES with 150,000 miles demonstrated in the lab. And now we're taking that next step to say, how do we get it into people's hands?
Great. Next, Dr. Josh Fujiwara from Honda. Over to you.
Hello, thank you very much for inviting this panel. Honda, like other OEMs, always require safety, reliability, and low cost. But we think that holy grail of low-cost battery technology is lithium metal anode, and due to high energy density. And most of the latest and most advanced research in the world are papers also focused on the establishment of this technology. And we will continue to collaborate. We are happy to collaborate with SES to bring this goal. Thank you.
Thanks, Josh. And next to Yongjun Zhang. Yongjun, would you like to make some comments on what you saw today from Chichao, and how are you thinking about new technologies such as this?
Okay, thanks, Mark. Recently, SES lithium metal battery technology is developing at a very rapid pace compared to the technology for about 30 years. It is very encouraging that the technology is improving by the manufacturing completeness of a large area 50 ampere hour class high energy density battery. If the stability of this battery is secured by applying AI technology, it will be of great help to the automotive company. From the point of view of application to vehicles, it is very important to secure a pressurization system to control uniformly large area batteries, as well as the long-term stability of high energy density batteries. Yeah, back to you, Mark.
Thanks very much. Robert, would you like to make some comments?
Well, it's been a year since we went around the sun in the first Battery World presentation. Since then, the world has continued to balkanize the world economy. The integrated world economy has broken down, and each geopolitical area is more concerned about their supply chain. So with our 40-year experience in mining, we are looking at the nickel, the copper, the cobalt, and the ultra-pure lithium metal required for the next generation of batteries. So our contribution is to understand the way the technology is going in the future and to get there first and provide the raw material required to get there from here.
Yeah, thanks very much, Robert. Alice, would you like to make some comments from your perspective and from Tianqi's perspective?
Yes, thank you, Mark, and thanks SES for inviting us to this event this year as well. And from our perspective, I was quite agree with what Chichao said in the script, that every player should actually have a great control of the supply chain at each stage. As we know, actually lithium-ion battery supply chain has very stringent product accreditation process. Therefore, it's important that we are taking control of each step of the supply chain to make sure we are producing the reliable and responsible products for the consumers. And regarding the second question of introducing a new technology to the market, and we are quite excited as well, but we still believe that it usually takes a lot of courage and time to introducing a new, especially a disruptive technology like the full solid battery to the market. But we believe it still will take some time to make it commercially into the market. That's basically the idea.
Absolutely, yeah. Thanks, Alice, for that. So I'd like to just talk a little bit more on some of the technologies here. So we've heard a lot from SES in terms of what they're doing in terms of lithium metal batteries. But I'd like to ask everyone here what what new technologies are you looking at in the field of batteries and electrification? New technologies such as lithium metal, but it can be something else, some other battery technologies or other technologies that you're really excited about. Should we go around roughly in a similar order? Tim, would you like to start off from GM?
Sure. And so I think there's several complementary technologies that we're working on to accelerate the introduction of something like lithium metal or other anode type designs. We heard about the need for a uniform stacked electrode with a constant pressure to get the durability and the integration in that. And actually having that complementary technology work with a lithium metal or some other thing is very synergistic on how we move faster, where we don't have to redo the rest of the system or the rest of the vehicle to actually introduce it. And we've got this ability now where, it's a bit of a very positive situation. In the US, we call it a blessing, but it's also a curse where we're expanding our capacity. And so as soon as the technology and the manufacturing process and the supply chain proves itself to be lower cost and more capable, we can do it as we expand. And we don't have to worry about retrofitting a manufacturing line or things like that. And it can coexist with other technology moving forward. And, I like to use a term that's, again, a US colloquialism, but it's called cooperation, where we're cooperating to say we can introduce this technology and other technology, and then the competition will be what's best for the customer, whether it be a 500-mile vehicle or a 300-mile vehicle that actually has a much smaller battery pack. And so we're preparing all that adjacent technology so that we can accelerate it into the marketplace as quickly as possible.
Great. Thanks, Tim. And Josh from Honda, what new technologies are you looking at? What are you excited about?
Yes, regarding to this electrified and also carbon neutral technology era, Honda, as I mentioned before, is focusing on safety and reliable and low-cost technology. And we have focused in two major technology trends. One is all-solid battery technology with lithium metal. That is one direction that we are success to realize such safety, realize reliability, and all low cost at the same time. And another thing is that we are focusing in is pure autonomous driving technology. That will be good for electrified vehicles as well. That's two major things that we are focusing and to realize within this decade, which is until before 2030. We'd like to issue that kind of vehicles into a market.
Great. And I'd like to just ask you, so you mentioned about all solid state, but how would you compare all solid state compared to the approach SES is making with the hybrid or liquid based, more lithium ion like manufacturing process? How would you compare those two technologies?
Well, we are actually doing both technology as simultaneously, and we are thinking about productivity and also reliability. And eventually, we'd like to reduce the price of electric vehicles. That we should focus in the cheaper way. Which one we don't know at this moment, but this technology, which is SES, is to utilize available liquid type LIB technology. Compare with that, solid technology is totally new. That's different things, but we are doing both.
Yeah, newer, so maybe it takes a bit longer, is what you're saying.
I don't know.
Okay, so then let's get some perspective from Hyundai. Yongjun, would you like to give us some of your thoughts here on new technologies you're excited about and what you're looking at?
After all, in order to make a battery with high energy density, lithium metal must be used for the anode. Furthermore, the composition of the electrolyte as well as the lithium metal is very important for high energy density batteries. This is because the long-term stability of the electrochemical redox reaction between the electrolyte and lithium metal anode determines the lifespan of the battery. The types of electrolytes used in high energy density batteries are high concentrated liquid electrolyte and solid electrolyte. As you already know, this high concentrated liquid electrolyte is used in lithium metal batteries, and solid electrolyte is used in all solid batteries. The final goal is to use lithium metal for both cells, but a different approach must be used to ensure long-term durability of the cells.
Mm-hmm.
In a lithium metal battery using a liquid electrolyte, it is necessary to induce a stable redox reaction to prevent excessive depletion of the liquid electrolyte and also the lithium metal anode at the interface. On the other hand, in a all-solid battery using a solid electrolyte, it is necessary to maintain a continuous close contact with lithium metal and prevent a short circuit of the battery by blocking needle-like dendrite. For these reasons, both electrolytes are very important factors that determine long-term durability in high energy density batteries. In particular, it becomes more sensitive and important in large area batteries rather than small area batteries. We should solve these issues for commercialization of the new batteries. Thank you, Mark.
I like the way you framed it there, because you were framing it lithium metal as the next generation anode, and then you were talking about two different pathways within that, the liquid approach and the solid state approach, which I think that makes it very clear, because I think a lot of people just get mixed up between solid state and not solid state, and they don't actually understand that lithium metal is actually, that's the thing that is the big jump in energy densities coming from the anode, and there are just a few different ways of enabling that, and you talked about them, solid state, and the approach that SES is doing with the higher concentration electrolyte.
Yes, right.
So I appreciate that. So Robert, over to you. What kind of new technologies would you like to talk about that you're particularly interested in here?
We're all about the electrification of everything, which requires us to completely change the way we conceive of and actually mine the resources in the crust of the earth. So since we have a very long lead time in mining and a lot of capital, we have to look forward 5 or 10 years and see where technology is going and what raw materials we'll need. And now that the world economy, which was so beautifully integrated as recently as 2008, is being balkanized, we need to find a lot of these critical raw materials in our own countries. So what's good for General Motors is good for the United States. And we're working now in Ivanhoe Electric in the United States to find all of these critical materials. In Australia, we're building the largest nickel and cobalt resource in the world that's not in the Democratic Republic of the Congo. And working in the United States, we're developing the largest and greenest new copper mine in Arizona. And we've identified very important lithium resources in the United States that can produce lithium metal quickly and efficaciously. So we've been looking at new ways to make lithium metal foil and the types of deposits that will enable us to actually do that. All of these sort of instruments will be part of the orchestra that's required for the United States to have its own secure domestic supply chain for these new technologies. And that's why it's very important for us to be part of this dialogue and see where we're going. And one inescapable conclusion is that lithium metal has the highest energy density on the anode side of the battery. So we will be a very low cost producer of lithium metal and solve part of that problem. For the copper and for the nickel and the cobalt, that's what we've been doing for the last 30 or 40 years. So we intend to make sure that the entire supply chain can be audited, can be very carefully studied, and can be done in a better and more energy sort of responsible way, quite differently from the way mining was performed in the past. And that's our contribution to this effort.
Thanks for that. Yeah, totally agree. Lithium metal is enables by far the highest energy density on the anode side. And as you said, that's one of the, being able to make it in mass production at low cost is still one of the big hurdles to mass production. So I think that's really great what you're looking at there. And I think actually it's a very similar topic here for Alice. Over to you from Tianqi. You're also a lithium producer, so perhaps you could tell us what new technologies you're looking at and maybe comment on some of the lithium metal stuff we were talking about earlier.
Yes, from our perspective, as an upstream player in the supply chain, our focus would be more on the lithium-related materials innovation, as we have 30 years expertise and experience in the lithium industry, and we mostly have the lithium business as our core. Therefore, we mostly focus on the lithium-related material innovation, such as the lithium sulfate and lithium metal. Of course, that's why we invested SES. We are trying to work with them, work with the downstream battery cell makers to make sure what kind of lithium materials they want. So we are customize that kind of material for them to be applied, used in the battery cells. Therefore, that's probably what we are focusing on.
Great. So is lithium metal a big part of Tianqi's strategy to be a lithium metal foil supplier as well? Yeah,
sure. I think that as what Robert has said, that lithium metal has already been the industry consensus that lithium metal would be hugely applied to use the solid battery in the next battery generation technology.
But great. I think Chichao, I wonder if I could just bring you in here before we go to the next question. Just get a chance, because you haven't had a chance to talk yet on this panel. You heard of lots of comments here on different next generation technologies from all of these different car OEMs, GM, Honda, Hyundai, Ivanhoe, Tianqi. Just, any thoughts from what you've heard today?
Yes, so I think first of all, we appreciate all the panelists participating and then supporting us. And then it's been a year, so it's good to have everyone back. On the new technology, really, I think it's about the whole system. And then, like Tim mentioned, at the end of the day, this cell needs to be integrated with the pack and then the car. And then there's a pressure system, the pack, the software, and then, like Robert and Alice mentioned, the upstream materials. So really, it's a system. It's not an individual electrolyte technology. It's not an individual anode coating technology. It's not going to be an individual technology or a collection of individual technologies that's going to change the world. It's really has to be a system. And then part of this is existing mature technology, optimized. Part of this is totally new, but it will really have to be a system that we need to develop and then have this entire new system to really change the world.
So it's an entire orchestra, not just the solo, is what you're saying. Yeah. So that's great. So I'd like next to switch topics to the supply chain. So we all know the huge supply chain ramp required in order to electrify all of cars, and all of transport is even greater problem. Considering that huge problem ahead of us, how are you all dealing with this? And particularly considering all of this new complication with new technologies that are being introduced, such as lithium metal batteries that we just talked about. And in addition, considering this new complexity that Robert brought up, which is this new kind of, well, relatively new, complex geopolitical environment and balkanization or decoupling of supply chains that we're starting to see happen now. So Robert, since you brought it up, maybe I just throw this to you first to start, if that's okay.
You know, the world's changed. We have tremendous pressures, and everybody knows the trends. We have the United States government has said that silicon chips made in the United States can't be sold to China, for example. Every action begets an equal and opposite counter-reaction. And so American automobile manufacturers have to worry about their supply chain. Chinese automobile manufacturers have to worry about their supply chain. The Korean manufacturers have to worry about their supply chain. The Japanese also, the Europeans. And so this has thrown an extra spanner in the works. A lot of the inflation that we're seeing in the world economy is not really coming from the demand side. It's easy to suppress demand when the Fed raises interest rates. Most of the inflation is coming from the supply side. When you balkanize the world economy, you stress the integrated world economy on the supply side. And that means that the critical raw materials we need to enable this energy revolution become even more important. And that's why we call this the revenge of the miners. The quantity of these metals that we need to stop burning hydrocarbon and coal are enormous, and they have to be supplied with highly scrutinized supply chains, very clean, very dependable, and very high quality raw materials. And so this is going to be a big challenge because the demand is like trying to get the contents of the Hoover Dam through a garden hose. You've already seen a big jump in the price of lithium in the last time we went around the sun, and big jumps in the price of nickel the last time we went around the sun. So our job is to find these raw materials, and in the case for General Motors in the United States or in Australia or in Canada, to make sure that we can supply this raw material to the American automobile industry. We have to live with the world as it actually is. And so it's going to make it a little harder, but if you want to change the world and you want to save the planet and you really want to make a difference, nobody said it was going to be easy. It's hard to make history, but this group is in the process of doing it. It takes a visionary like Chi Chow to be very forthright about how many individual challenges have to be overcome to win this battle. This is the company that's actually going to do it, if anybody's going to do it. We looked at all of them when we had our SPAC. Mark, you and I worked together, and we looked at the entire battery industry, and we saw a lot of claims with competitors that were absolutely bullshit, frankly. This company is honest and is directly, publicly disclosing all of the key numbers on the way to the revolution. And the shareholders, the stakeholders, are an interesting combination of upstream suppliers, like a Chinese lithium producer, or ourselves who produce nickel, copper, cobalt, other metals, and major international automobile manufacturers. And we're coming together in a way that hasn't happened since the Iron Horse required iron and hydrocarbon to start when Henry Ford started mass producing the automobile. So this is it, unfolding in real time. The miners are super important. Government support to the miners is super important. We now have the so-called Inflation Reduction Act in the United States to help people like us find the raw materials in the United States to support this transition. But a lot of the technologies in Japan, a lot of the technologies in Korea, a lot of the technology has come from China. And that's why I do think we're better off cooperating globally than just tearing ourselves apart into disparate little pieces. The world needs to work together, because if we're going to have a new way of transporting the automobile industry that's clean and green, we have to work together. And that includes the miners. So on behalf of the mining industry, we're here and we're up for the challenge.
Great, thanks, Robert. From one miner to another, from Ivanhoe to Tianqi, Alice, would you like to talk about how you're seeing the challenges ahead in the supply chain?
Yes, actually, I think the coming out with the IRA has already putting out the fact that the whole global supply chain is shifting. We are believing that the globalization supply chain that has been built in the past decades will probably change in the next few decades to be more localized at the major consumer market, such as localized at the US, the European, and the Asian markets, as the IRA has already clarified that most of the critical minerals and materials should be produced or assembled at the US. Therefore, we think it's a trend that in the future, maybe European will have their own battery act to have the same kind of behavior. Therefore, as what Robert has said, as a mining company, maybe we also have some leasing chemical business, but as a very upstream player, for us or as a corporate, it's important to choose our next location of expansion to comply with the trend, comply with the flow of the geopolitical tensions.
Okay, thanks, Alice. Let's hear some thoughts from some of the automotive OEMs. Tim, some comments from you on how you're dealing with this supply chain ramp and all these complexities?
Yeah, absolutely. I'd like to start off with, I really resonate with what Robert said, where, we can do this and we can get through it together. I think Xijiao talked about the tunnel of hell to get to heaven as well. And we just see it as the tunnel to heaven, and it's coming. So we get through all of this transitional time as quickly as we can. And so from a raw material point of view, we have binding agreements to secure all the raw material we need for 1 million vehicles annually in North America by 2025. And expanding that, we recently announced that we're on track to get 5 million vehicles annually by 2030. And so the minerals are there. And like Qijiao said, it's all about the entire system and the entire manufacturing process and how do you do it at low cost to tie it all together. And that's the tunnel that we're operating in right now, to say, how do we make all that achieve so we can get to this heaven moving forward? And even beyond the cost and the material processing and great discussions on electrolyte and everything matters, it's then, well, how do you make the most of it once it's in the vehicle? And so how do you do the total life cycle, the circular nature of these minerals? And we talked about the data farm and the ability to track this and then get into recycling. And while you're actually doing this expansion and this scaling right now, how do you make sure that you have the information so you can optimize the future when it gets to recycling? And so, securing the base materials is well underway, 1 million to 5 million. In this decade, getting all the rest of the system where that lithium metal and the foil can turn into a cell factory and an anode line, and then it can be integrated into a cell assembly and into a vehicle assembly, and then into a data stream where we make the most out of it at every phase of its life, and then bring it back in recycling is where we're at. And so we think we have the binding agreements. These are not MOUs or non-binding agreements. These are binding agreements to get the base materials that we need when we need them. Now, how do we make it so that it's actually got the higher performance, higher energy density, and the information to last the life of the product?
And how much do these political uncertainties drive decisions for, say, location of your supply chain? Because the fact of the matter is, most of the supply chain today is coming from China, or it touches China, goes through China in some way, processing or mining or some part, cathodes, anodes, etc., batteries themselves. Majority is actually going through China in some part. So how much of a big concern or part of your decision-making process is that?
So I think other panelists talked about it very well, right? There's going to be, as we expand into this light duty, high volume application, there's going to be a natural localization. That's true for anything that we do in a high volume automotive business. And now having some of these accelerants, right? We talked about the Inflation Reduction Act or some of these other moves by the miners to actually have it become more local where the people use the product, and then we can have that whole ecosystem develop, is accelerating it. We always, you know, one of the most important things in high volume manufacturing is securing stable supply, and that's always high value to us. And so that's fundamental in our business model to say whether it's local or whether it's a friendly country or whether it's a more difficult supply chain, how do we make sure we never get a production interruption? And we have a numerous amounts of processes and contracts to make sure that that happens.
Thanks, Tim. Josh, how are you and how's Honda thinking about these challenges ahead?
Yes, basically our principle is localization. From the beginning, last century, we built a factory in the United States. Then basically we are not exported from Japan. Always we build the factory and also the supply chain built in the local. So I think next electrify also the same trend and same way, we will do the same way. And especially where Honda is focusing in the two major areas for the electrified and also the sales in the US and China. Both has a different, actually different, and we need to establish different supply chain individually. So in particular, due to IRA, the Honda seek to establishment of the supply chain in North America is very important things and urgent issues. So that we as Chicho mentioned, that to control or to integrate all the supply chain in local is pretty important. That we believe. Thank you.
Thanks, Josh. Yongjun from Hyundai. Any thoughts from you on this topic?
It is not an easy issue for supply chain, but we should work through it together. From the automotive company's point of view, there is an example of recycling of waste batteries. Many companies in the world are interested in recycling waste batteries in order for recycling companies to increase their profit. The supply of waste batteries still needed to increase more. During that period, recycling technology of waste battery needs to be further matured and stabilized. I think this method seems to be able to serve the supply chain to some extent.
Thanks very much. And then finally, Chichao, we've already heard some of your thoughts during your keynote, but would you like to add something? There's been quite interesting discussion here, I think, from these panelists. Anything to add from you?
Yes, I think the first part, in terms of ramping up supply chain for new technology, for our lithium metal, it actually shares a lot of the supply chain with lithium ion. For example, the cathode, the manufacturing process, all that is the same. And there are parts that are different. For example, this lithium anode, and then the current supply chain for lithium anode is very compartmentalized and then very fragmented. You have several companies involved, and then cost, process, all that are just very inefficient. So we are working with our partners to basically try to make that process as possible, from the mine to the final anode, as simple, as streamlined, as optimized, and then as fewer players involved as possible. And then I think that could be a really key factor to ramp up the supply chain for lithium metal batteries. On the second part, on the geopolitical issues, so currently we are pre-commercial, and then we are working with this global supply chain, as we all see on this panel together. And then, like Robert mentioned, things are so much easier, and then we can do so much more when we work together. Now, we also do recognize this manufacturing renaissance in North America, and then North America does have a lot of potential for a lot of these manufacturings. Abundant raw materials, fairly low cost electricity, and then access to well-trained labor, high technology. So we are preparing to actually build this entire supply chain, and then help build this entire supply chain. For example, electrolyte, anode, cell in North America. It actually, this trend offers a lot of opportunities.
Exciting stuff. Well, I think we're just about out of time. So I think we've had a great discussion. We talked about some of these new technologies, and we talked about these huge contentious topics of the supply chain, including the political uncertainties ahead of us. I think I'd just like to thank all the panelists for joining. Tim, Youngjun, Josh, Robert, Alice, Chichao, thanks all for joining. It's been great. Thanks for joining, and I hope you can come back for our next event. Thanks, everyone.
Great to be here.
Thank you.
Bye-bye.
Bye.
好的，非常感谢大家参与今天的线上活动。锂金属电池是一项非常令人期待的下一代电池技术，对于未来的能源转型有着巨大的意义。SES 会不断努力，把锂金属电池做成功，也希望大家可以持续关注我们。感谢各位的参与，谢谢，下次再见，明年再见。